Before we get started on this chapter's material, make sure you have your factoring down. We will be doing an incredible amount of factoring in this chapter. If your factoring skills are weak, you will only get slowed down in the work in this chapter or possibly not be able to get through it. With that said, let's get started. The definition for a rational expression is a quotient of two polynomials. These expressions and functions are going to be in a fraction form. Check out the form for the examples of rational expressions. An expression is not set to anything, while a function is set to y. The domain of a function is a set of permissible values for x. What would be a reason for restrictions on x? What is something that we can never do in mathematics? Well, division by 0 is not defined. Therefore, all values for x that cause us to divide by 0 must be eliminated from the domain. These values are referred to as restricted values. With rational functions, we approach finding the domain by finding the restricted values. The domain will then be all real numbers except the restricted values. To find the restricted values, set the denominator equal to 0. For this one, we can easily find the restricted values. X cannot be 5. Therefore, the domain is the set of all real numbers except 5. For now, we'll use set builder notation. Notice how the domain is stated in set notation. Inside, we start with x to let others know we're stating the permissible values for that variable. We draw a vertical bar that you read as such that, and then after the vertical bar, we define the permissible values. Here is one way to read this. The domain is a set of all x such that x is any real number with the exception of 5. The degree of this denominator is 2. We could see up to 2 restricted values. We take the denominator off to the side to find the restricted values. X squared minus 4 is the difference of 2 squares. We factor this for the 2 restricted values of -2 and 2. Stating the domain with set builder notation, we get the domain is a set of all values of x such that x is any real number with the exception of -2 and 2. Let's take our discussion back to rational expressions. If you recall, when you were first introduced to fractions, we said final form needed to be stated in lowest terms. It doesn't matter if the numerators and denominators are whole numbers or polynomials. We still expect lowest terms. Before we talk about the problem on the last slide, let's discuss the form the rational expression must be in order to reduce. One example has addition between the numbers in the numerator, and the other has multiplication. Of the 2 examples, we can only cancel the 2's for the second one, the one that has multiplication between the numbers. We cannot cancel the 2's of the first problem due to the addition between the terms of the numerator. To get multiplication between, we start by completely factoring. Once you have factored, then and only then can you cancel. Now back to the problem. We now know why we must factor first. That gives us the multiplication between and therefore the ability and the right to cancel common factors. After canceling the x minus 5 factors, we now have the answer in lowest terms. Again, we must factor first. Notice how the numerator does not have its terms in descending order. That will not be an issue for factoring, but it could possibly for reducing. So I'm going to start by factoring out a negative from the numerator. Notice how this changes the sign of both terms. With that done, I can switch the -16 and x squared to get the terms in descending order. The negative will need to be kept for the final answer, so don't drop it. Now I'm ready to factor. Once completely factored, we can cancel off the x minus 4 factors. If we had not factored out the negative in the numerator to begin with, these factors would be opposite in sign, and we would still be needing to factor a negative to get them the same. It's always best if that step is done earlier on. Let's talk about what to do if 2 factors are opposite in sign. Notice the 2 terms are opposite in sign from the 2 in the denominator. If I take a number and divide it by another number opposite its sign, like 3 divided by -3, the result is always -1. Here I'm showing why the answer is -1. Pick either of the 2 factors and factor out a -1. It doesn't matter which one. Notice how the x minus 5's will cancel, leaving with a negative or a negative 1. If you know that your two factors are opposites, you don't need to be formal about showing the result of negative 1. Simply cancel and replace it with negative 1.